remember the strategy for binomials. If we are asked to factor a binomial, we will make sure that it's in descending order. If it has a common factor, both terms, if they have a common factor, we pull those out, one or more. If it has a negative leading coefficient, we pull it out. And then we have several options here. And we only talked, right? We only talked about the first two, correct? Or just the first one, right? Yeah, the first one. So we're going to talk about the last three now. So the a squared plus b squared, it's not factorable. To be exact, using integers. In other words, we are really not interested in factoring it if we cannot factor it using integers. Later on in higher math, we do factor it, but in a specific way or different way than what we need right now. So we're not going to talk about that. So the sum of squares will say it's not factorable using integers. We do have two other special products. First of all, what do you think these are called? Just give it a shot. Of course, the sum of cubes and the difference of cubes. Of course. These are cubes, right? This is, they are factorable. So the sum of cubes and the difference of cubes are factorable. Now, they're very special. They're nothing that you're going to experience again. Very different. So they both factor into a binomial first. It doesn't really matter. And a trinomial. A binomial and a trinomial. Nothing else factors like that into a binomial and trinomial. First, we will talk about the sequence of signs. And then we will figure out what it goes in here and what goes in here. If we factor the sum of cubes, the binomial will have the sum. If we factor the difference of cubes, the binomial will have the difference. Right here in the middle of the trinomial, just in the middle, there will always be the opposite sign. If these are positive, I'll have a minus in there. If these are negative, in the middle I'll have a positive. So now let's figure out the rest. First, of course, we will start with the binomial. What do you think we cube to get a cubed? What will I raise to the third power to get a to the third power? Of course, there is no doubt. What do you think we raise to the third power to get b to the third power? Of course. So the binomial is not a problem. The trinomial should not be a problem either. Here's how it goes. We will square the first term. We will square the last term. The last term, we don't even talk about the sign. It's always positive. That's why I didn't even mention it. And now let's talk about the middle term. The middle term is just the product of the two factors, of the two terms, just AB. Bless you. Okay, that's it. Of course, I should not remember it like this. How should I remember it? As the first term plus the second term times first term squared minus the product of the two terms, first and second, plus the second term squared. Because I'm not going to get A and B. A and B is just generic, right? I'm not going to get A and B. So let's take a look at, back to the handout, let's look at E. 1 over 27 minus x cubed. Remember the strategy, please do not skip. I'm asking myself what type of polynomial is it? And the answer is binomial. Is it in descending order? No. Very good. Awesome. So how do I rearrange it in descending order? Yes, please.
Make it negative x to the third plus 1 and 27.
Excellent. Negative x to the third. Remember, the term comes with a sign in front. You cannot separate the term from the sign in front. Good. So we arrange it in descending order. Now, is there greatest common factor present in both? Is there? No, of course not. X cubed and 1 over 27 have nothing in common. Good. Is there a negative leading coefficient?
Yes.
We have to pull it out. Now we have to figure out what is left in parentheses. What is left in parentheses? Awesome. Careful.
Minus.
X cubed minus 1 over 27. Do you all see that?
Mm-hmm.
Very good. X cubed minus 1 over 27. So now I reached this stage. Now I have 4 different options. Yes?
Isn't there a way to flip the 1 over 27? There's something I remember.
You want to write it as 27 to negative 1?
Yeah.
Or 3 to the negative 3?
I think I was thinking about 27 to the negative 1.
Correct. It's perfect. But we really don't want to do that because we want to factor the difference of cubes. But you're right. It's another option, another way of writing it. Okay, so I see minus in between. I remember the 4 special products. Obviously, I can only consider this and consider this. I cannot consider the plus. I cannot consider the sum of squares and the sum of cubes because I don't have a sum. I have a difference. So these two are competing against each other. So now I'm asking myself, are these terms perfect squares or perfect cubes? They are perfect cubes. Very good. What do I cube to get this? And what do I cube to get that? Once you say, hold on, forgive me for interrupting. Once you say that this is the difference of cubes, then you will prepare a binomial and a trinomial. Okay, so now please tell me what you could cube to get x to the third and what you cubed to get to 1 over 27. So let's start with a sequence of signs. If we factor the difference, we always have the difference. If we factor the sum, we always start with the sum. So then,
X cubed
so what is the sign?
minus.
Yes, what is the sign in the middle? Okay, and the last one is always positive, and that's why we didn't even talk about it. Good. So what will I put here? What do we cube to? Very good. And what do we cube to get 1 over 27? Perfect. 1 over 3 times 1 over 3 times 1 over 3 is 1 over 27. So then I have the binomial. Can anyone identify it? It's right there in front of us. Excellent. Now I know the pattern for the rest. I square the first term. What do I write? Excellent. I square the last term. What do I write?
1/9.
Yes, 1 over 3 times 1 over 3 is 1 over 9. And what do I have in the middle? Excellent. That's it. It's not too difficult. Once you understand it and you see it, you can, right? Good. So let's take a look at y cubed plus 8. And let's move on to trinomials after that, unless you need more examples. Okay, I go back to my strategy. What is it? Perfect. Is it in descending order? Negative, greatest common factor. Negative leading coefficient. No, I'm down here. I have only 2 options. It's either the sum of squares or the sum of cubes, or it is not factorable. I should say 3 options. Very good. Once you say the sum of cubes, you will immediately prepare a
Binomial.
and a trinomial. Excellent. The next step is the sign. The sequence of sign, very important. So what do we have in the binomial?
Negative, positive, positive.
What do we have in the binomial?
Positive.
Positive. If we factor the sum of cubes, we have the sum in the binomial. And what do we have in the middle of the trinomial? Negative. And what happens in the last term? We don't even talk about it. It's a waste of time. It's always positive. Good. So now we have to identify what we cube to get y to the third and what we cube to get 8. And that's our binomial. Very good. So square the first term, square the last term, and in the middle, just the product without the 2 from another formula. Don't confuse this with the other formula. So what do I write in the middle? That's it. It's not a difficult pattern, but we will forget if we don't practice, right? Please remember that. Okay, so finally, let's move on to trinomials. Back to the handout. Luckily for trinomials, we only have 2 special products. Have we ever seen these before? Yes, on the first handout. That's why I started with that. Right? What did we say? A binomial squared has how many terms?
3.
Okay. So now we're going backwards. We are given the 3 terms, and we're asked to factor this. So how will you factor this? Go back to the first handout. We just talked about it. We just reviewed it a minute ago. What is this? How do we factor this? Everything squared. Awesome. A minus b in parentheses, everything squared. Perfect. What is this? In parentheses, everything squared. Excellent. And then we have other options of factoring. Well, I'm going to get to this in a minute. Yes? Yeah. You mean make it warmer?
Yes, like not hot.
Let's see if this is better. Okay. Let me know. Of course. Okay, so here they are. You can write them again. Can anyone dictate again? What do I write for this? Very good. What do I write for this? Excellent. Okay, so I'm going to start with y squared plus 121 minus 22y. Any questions in the back, ladies? Any questions? Any questions? Okay, ready. Here's the strategy. Please do not skip any of the steps. What type of polynomial is it? Good. Is it in descending order? No. The answer is no. How do I rearrange it? Yes? Very good. Excellent. Is there a greatest common factor present in all 3? No. Excellent. Is there a negative leading coefficient? No, there isn't. So I finally got down to the strategy of special products first. Will I think of this or will I think of this? The first one, because the middle coefficient is negative. Excellent. Good. So now I'm not going to look at the middle term, and I'm going to say, is there a quantity that I squared to get y squared? Yes, it is y. Is there a quantity that, of course, with minus? Is there a quantity that I squared to get 121? 11. What do you expect this to be? Very good. So we came up with this conclusion of y minus 11 squared, only looking at the first term and the last term. We haven't checked the middle term. So, but I know how to check the middle term, right? Because where is my first handout? When I expand this, I get a squared minus 2 times a times b plus b squared, correct?
Yes.
Okay, so now please give me the middle term of this expansion. This will, so minus 2 times, so 2 times y times 11, right? Correct? The first term squared minus 2 times the first times the second plus the second term squared. Is this identical with this?
Yeah.
So this is the correct factored form. So the point I'm making is this. It's not sufficient to simply look at the first and the last term. If you don't check the middle term, you may be wrong. So here's a counterexample for you. Y squared minus 11y plus 121. If you write this, you know it's incorrect. How come it's incorrect? Because the middle term here is, exactly. But do I have negative 22y here? No. So this is then not the correct factor form. And it turns out it's not even factorable. So again, the point I'm making is when you're trying to fit a special product and you check the first term and the last term, it's not sufficient. You have to take a moment and check the middle term. Is that clear?
Yes.
Yes? Okay, perfect. Let's move on to part B, another example. Let's say negative 3x squared minus 12x minus 12. Can anyone walk us through the strategy for this one? What do you ask yourselves first? What type of polynomial is it? Let me explain why. Because if it's a binomial, I will follow this path. If it's a trinomial, I will follow this path. And if it's something else, I will follow this path. So putting it in the right category is extremely important. So then, first question is, what is it? Indeed. Second question, please. Okay, is it?
Yes.
Perfect. Next question.
Let me figure it out.
Does it have a greatest common factor? Good. Does it have a negative leading coefficient? Good. So let's pull them out at the same time. Negative 3. In parentheses, please. Plus? Excellent. Good. So now let's look inside. We reach this stage. Do I try to fit this or I try to fit this? First or second? Yes, of course, because the middle coefficient is positive. So without looking at the middle term, what will you conclude? X plus 2 everything squared. Is it sufficient? Can you walk away and look at the next problem? The answer is no, we haven't checked the middle term. What will be the middle term here? 2 times the first times the second. What will be 4x? Is this 4x? So therefore, this is the correct factor form. Okay, very good. So let's look at one more and move on. Let's say a squared plus 6a plus 9. The more we practice, the faster we can go, right? You're Taylor, right? You didn't give me your information last time, so can you please fill it out? Because I considered you absent last time. I knew you were here, but you left without me. So please fill it out. Okay, so quickly now, right? Trinomial, descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, I always hope for a special product. Special products are much easier than anything else. So, if it is a special product, what will you conclude? Excellent. What will be the middle coefficient here?
6.
Yes, you're right, you're right. I just wanted to start from scratch. What is the middle coefficient here?
6a.
Middle term. 6a, indeed. Is this 6a? So please remember, do not disregard the middle term. Okay, moving on. We're moving on to this type of trinomial that is not a special product, and it has 1 as the leading coefficient. Okay? So the next step, let's look at x squared minus 20 minus x. Ready? Okay, quickly, can anyone walk us through? Quickly. I'm tired of hearing myself.
Trinomial.
Say it again.
It's a trinomial.
Trinomial.
Not in descending order.
It's not in descending order. Can anyone dictate? Excellent. Then,
It doesn't have any greatest common factor.
excellent.
There's no negative code.
Excellent. Now, this is a different story. Is there a special product? Can I apply a special product here?
No.
No. First of all, because the last term is negative. And secondly, it's not a perfect square. Oh, you had it. Thank you. Okay. I hope I see you on Wednesday. We're closed on Monday. Okay, very good. So obviously, when I reached here, I went through all the steps. I said, no, I cannot fit this. Now I have to identify whether the leading coefficient is 1 or not 1. That's the same, but 1 and not 1. Is it 1?
Yeah.
It is. So it's this situation. Okay, perfect. Here's what we're looking for right now. Two numbers whose product is negative 20. And the same numbers whose sum is this coefficient. In this case, is negative 1. It is very important to follow through, so please pay attention. How do I try to find these numbers? Is this. I first look at the product. Because the product is negative, the product of two numbers being negative, I know that one has to be positive and one has to be negative. That's where I start. That's my starting point. The product being negative, one must be positive and one must be negative. Please.
It's 4 and -5.
4 and -5. So 4 and -5. Both conditions have to be fulfilled. The product is negative 20. The sum is negative 1. Mandatory. So therefore, I directly go and factor this. Yes? Exactly. Yes. Okay, let's say we have doubts about this. It takes 5 seconds to check. X times x, x squared. Negative 5x plus 4x is negative x. And 4 times -5 is negative 20. You don't need anyone to tell you whether this is the correct factored form. You don't need me or anyone else. It takes 3 seconds to check. Okay, and next one. Let's say x squared plus 13x plus 36. Okay, can anyone help? Yes, descending order.
Yes.
Greatest common factor. Negative leading coefficient.
No.
Special product. Yes. Okay, what do you expect?
X plus.
Excellent. Awesome. What is the middle term here? No, it's not 13. So this is 12x, right? Now, is this 12x?
No.
Okay, so then I'm looking for two numbers whose product is excellent and whose sum is excellent. This is always the product and this is always the sum. Since the product is positive, that's my starting point. Since the product is positive, I am looking for two positive numbers or two negative numbers. But since the sum is positive, which one is the case? Of course, this makes no sense. How can I add two negative numbers and get positive 13? Well done. So can we find two numbers whose, yes?
9 and 4.
Okay, what did you have? 9 and 4. So indeed, 9 and 4, 9 and 4. So then we go straight to factoring it. Excellent. So it doesn't matter. The order is not important. If you write x plus 4 times x plus 9, it's still the same thing. Okay, last possibility, which is, of course, the most difficult one. Cumbersome, I wouldn't say difficult. Okay, so let's start with 6y squared minus y minus 1. Can anyone walk us through quickly? Trinomial?
Yeah.
Great. Descending order?
Yeah.
Greatest common factor? Very good. Negative leading coefficient?
No.
Very good. Stay with me, stay with me. Special product?
No.
Impossible, right? Because first of all, this is negative, and first of all, this one is not a perfect square. There's nothing that I can square to get 6y squared, so obviously not a perfect square. Is 1 the leading coefficient?
No.
So I cannot use this one. So this is my last option, in which the leading coefficient is not 1. Okay, so please pay attention to this strategy. It's a long strategy, so pay attention, please. You can use other methods. I just present the one with the factoring by grouping. Yeah, but you can use any, right? Okay, in this case, we are looking for two numbers whose product is this product. This is the product. Now, it was the same thing here, negative 20 times 1, but I didn't say it, right? But here, we have no choice. Negative 1 times 6, which is negative 6. The sum does not change. The sum is always the same. In this case, negative 1. So since the product is negative, that's the starting point, right? We are looking for a positive and a negative. Excellent. Negative 3 and 2. Both conditions are fulfilled. The product is negative 6. The sum is negative 1. But now please pay attention what happens next. And of course, if you know a different method, I fully accept it. Okay. I'm going to continue from here. We will replace this term using these numbers that you just gave me. So I will write 6y squared minus 3y plus 2y and minus 1. This is still negative y. We did not change the problem. We changed this presentation, the outlook, but we did not change the problem. At this point, we will factor. Do not go back and combine like terms, because you're going backwards. We're going to factor by grouping. Please tell me what you would factor out from the first two terms as if they were by themselves. You will factor out? Excellent. What is left in parentheses? Yes? No? Yes? Say it again. Of course, we have two terms. We have to have two terms in parentheses. What has to come from the other two in parentheses so we can continue? Mandatory. I will not even look. I refuse to look. I want to write it first. What do I have to have here? Mandatory. Then I will never be able to continue factoring. Right? Do we see that? So what do I have to have here? I'm talking about in parentheses. I'm not asking about the sign. What do I have to have in parentheses so I can continue? Exactly. 2y minus 1, of course. If I don't have the same thing, I will never be able to continue. I will not be able to factor if I don't have the same thing. Only now I look. I need two things from you. A sign and a factor. What times 2y is 2y? What times negative 1 is negative 1? Sign. As I said, I need the sign. If I don't put the sign, I mess up the whole thing. And the factor. Exactly. Plus 1. So now this is a term, and this is a term, and they have a common factor that I need to pull out. Please tell me which common factor we will pull out. Say it again. Of course. What is left in parentheses from the first term? What is left? Plus 1 from the other term, indeed. So I don't believe this. I just want to check. 2y times 3y, 6y squared. Positive 2y minus 3y is negative 1, negative y, and negative 1 times 1 is negative 1. So let's practice this. Let's look at 4x squared. minus 4x minus 15. Yes, any questions in the back, ladies?
No.
Please choose the method you like. If you don't know any method, please use mine. If you prefer a different one, I'm fine. Okay. Can anyone walk us through the strategy quickly? Is it what? Excellent. Is it in descending order? Greatest common factor? Negative leading coefficient? Special product? I always hope for a special product. Is there a special? No, of course not. Is 1 the leading coefficient? So we're down to the last possibility. If not, I'm going to write it's not factorable. Okay, so then I'm looking for two numbers whose product is exactly 4 times negative 15. This is the product, indeed. And whose sum is excellent. Remember, the product is negative, so we are looking, we are looking for a positive and a negative. So I need two numbers, a positive and a negative, whose product is negative 60 and whose sum would be negative 4.
Negative 10 and 6.
So what is it?
Negative 10 and 6.
Negative 10 and positive 6. Okay, the product is negative 60? Yes. The sum is negative 4? Yes. Can anyone dictate the next step? Please.
4x
Excellent.
minus 10 x
Excellent.
plus 6x
Excellent.
minus
Awesome. Do we all see that? Yes? Everyone?
Mm-hmm.
Good. So please give me the factor that you pull out from the very first two.
2x
Excellent. And what do we have in parentheses? 2x minus 5. What you will copy immediately before we even look. It's very important. And now I need a sign and a factor.
plus 3.
Excellent. Well done. It's not that bad. Once we practice a little bit and we understand it and we see it, it's not that bad. So then what do you pull out?
2x
Yes, it's the common factor. Very good. And then in parentheses?
plus 3.
Good. Is it clear? It will go away between now and Wednesday if we don't find time to practice. So do you think we should do another?
Yes.
Very good. Any questions? Anyone? Questions, please. Questions? Anyone? Okay. Don't be shy, please. Let's say 5x squared minus 26x plus 5. 1 minute. Let's work on this. Yes, please.
Are we allowed to use the quadratic formula?
Yes, you are. But then, do you know how to go backwards and put the form in? I have to show you how.
Okay.
You can use the quadratic formula. Yeah, I accept that. Okay, 2 minutes. Okay, please work on this. And I'm going to take attendance and see how much I remember. Because I met another 50 students yesterday, so of course just a few of you I do remember. I'm going to check my memory now. Come on, computer. I didn't see everyone registered in my lab math yet. Please do it. Please, please. Okay, Taylor just left. Vinny is here. Oh, you're Taylor. Okay, she's the second. Okay, so you're Allison, right? Thank you. My apologies. Vinny is here. Ariel. Yes. Okay. Trevor. Thank you. Jay.
Here.
Good. Mason. Mason. Talia. Thank you. Jordan. Thank you. Dylan. Alex.
Here.
Okay. Tim is here. Kendall. Michaela. Tatiana. Thank you. Z is here. Yes. Elizabeth.
Yes, you can.
One.
Yes. Dana.
The same way.
One times
Antoine is here. Brian. Perfect. Heather. Right here. Yes. And Lani.
You're right. How about
Thank
they're
you.
all There.
Excellent. Thank you, guys. Okay, we have the answer.
We had a brain fart up there. Look what people did. So.
We have the answer. Do I have to show it or not? Okay, perfect. So we go through the strategy. Please, please, I don't mind. I'm going to beg you many times in the next 15 weeks. I'm begging you, do not skip anything here. Do not skip any step because you're making your life more difficult. So first of all, identify it as a trinomial. It's in the middle category. Then I know it's in descending order, no greatest common factor, no negative leading coefficient. It's not a special product because a special product requires perfect squares here, and 5 is no way a perfect square. 1 is not the leading coefficient, so I cannot use this easier strategy. I have no choices but the last one. So I'm looking for two numbers whose product is 25 and whose sum is good. Remember, the product is positive. You have two options. Yes, but since you look at the negative sum, you know that this is not possible. Okay, so negative 25 and negative 1. Perfect. The sum is negative 26? Yes. The product is positive 25? Yes. So then what will you write next? Yes? Excellent. Good. So now you will factor out from the first two. Indeed, 5x. And what is left in parentheses? Without looking. Indeed, it has to be the same. Otherwise, how do I know it has to be there? Here's how I know it has to be there. Because we were able to find the two numbers whose product is negative 25 and a positive 25 and sum is negative 26. I know that factor has to come out from the other two. There is no doubt. That's why I write it from the beginning, because if I don't, I may make a mistake and write x plus 5, and then I'm messing up the whole thing. So I need a sign and a factor. Indeed, we don't really write the one, but that's why I put it like that. So now the common factor from both is, and what is left in parentheses? Good. Final strategy is always the easiest. The last possibility is always the easiest. Of course, we have to go through everything, but look at this. There's nothing there but what we just did, factoring by grouping. Okay, ready? So let's take a look at, let's say, 2x cubed minus 6x squared plus x minus 3. There is nothing, right? What is it? Excellent. Descending order, greatest common factor, negative leading coefficient, factoring by grouping. Done. So what comes out from the other two, from the first two? What is left in parentheses? Okay, what should, now I'm not certain. I may have to rearrange them. Remember, we have 4 terms now. I may have to group the first two and the last two. I may have to group the first with the third and the second with the fourth. I don't know. Or I may have to group the first and the last and the middle two separately. I don't know. But I'm hoping that I can get what out of the other two? Yes, that's what my hope is. Good. So now let's look if it's there. I cannot fabricate it, right? Excellent. So that's it. Good. So I consider this done, which means that I'm kindly asking you to finish between now and when we meet again the factoring assignment, right? It's an extra practice factoring assignment in my lab math. Okay? Yes, I showed it to you last time.
Yeah.
Do I need to show it to you again? Once you log in, you will have access to it. Is that okay? So I consider factoring done. I consider that we know that a binomial squared is a... Excellent. Okay. So now finally, okay, so moving on, let's see what is in this chapter, chapter 1, that we can... Yes, please.
Do we have to remember do we remember all of this? Like by heart?
Yes, please. Yes, that's why we practice here, and that's why I highly recommend that. Now, the first section in chapter 1 that we have to look at is how to use a graphing calculator to solve a few things. So let's take a look at something there. Maybe we want to... any questions for me? Ladies, any questions? Any questions? Okay. So let's take a look on page 103. I'm going to just graph each equation. Okay, I'm just going to show you how to graph an equation. We're going to do this. I'm not going to spend too much time on it. We're going to do this all the time, the entire semester. We're going to use the graphing calculator for something.